Welcome everybody to my tutorial. Today I will show you during this video how to toggle the LED on the STM32F4 discovery board using IAR embedded workbench. Before, in the previous tutorial video, we turned on together the LED. You can watch this video by clicking in the right top corner right here. Now let's see our this file, the device overview. So let me explain you something. So this is the Cortex M4 delivered by and designed by ARM company, and here the other thing, the peripheral, are designed by ST. So we are so the SysTick timer, this is not this timer 9, timer 10, timer 2 or timer 3. This is a timer included in the Cortex M4. So here we are in a special case. So let's move on. I will see you how to do that. So here we are in our first part. So we're gonna find the function to configure our SysTick timer. So we go to the driver opnet, go to the library CMSIS, go to include, and here we have the Cortex M4. We opnet and we go down here till we found a SysTick configuration. So there's our function. This function initializes the SysTick timer and it interrupt. So we copy this and we paste here. We write here SysTick configuration. So here let me explain you or remember you what is a timer. A timer is a hardware device for measuring the time. Timer is generally a countdown which have initial value decreasing till reach the zero. When the timer reach the zero, an interruption is triggered. So the time separating two interruption is equal to the initial value multiplied by the decreasing tick time. So the decrease in tick time mean the time need, for example, to go for 1000 to 99. So let's go back here. Here the SysTick, here the first parameter here, which should contain the number of tick between two interrupt. So here we have to put the number of tick. So as we know that the SysTick have the same clock as the system core clock for the ARM. So for example, if we put here system core clock, what mean system core clock? A core clock, what mean? So our core clock of the ARM is 168 megahertz. That mean 168 million tick by second. If we put this 168 million tick per second, so the time separating between two interrupt, it will be equal to 1 second. So if we divide this by 10, we have a time separating between two interrupt equal to 0.1 second. Well, that means 100 millisecond. If we divide this by 100, we obtain a time separating two interrupt equal to 10 millisecond. If we divide this by 1000, we obtain a time separating two interrupt equal to 1 millisecond. So we're gonna put this, we're gonna put the time 1 millisecond separating two interrupt. So we have to be careful in this condition here. The tick, if the tick is superior at this value, the reload value is impossible. The maximum tick value is equal to 6f in hexadecimal, is about 60,777,215. We finished the configuration. Let's see how to deal with the interruption. So after the configuration, the only thing we know that the time between two interrupt is about 1 millisecond. So we move on here. I will show you how we will write the code for the LED toggle right here. So we write LED toggle and we're gonna create a loop right here while and 1 and and we're gonna insert here, we're gonna insert a delay of 500 millisecond. So we're gonna add a new function called delay. I will put right here 500 millisecond, and next I will toggle the LED. So for toggling the LED we have two choices. We can choose a function inside the GPIO source file. We can use the GPIO toggle, or you can use the driver discovery. You can use this STM eval toggle. So we're gonna use this. We're gonna copy this and we paste right here, and I'm gonna select the LED number 6, of course. So now we're gonna declare our function delay here. So we're gonna put void delay. We're gonna add this kind. I will explain you later. 32 and T, and we're gonna call this one time, this variable time. The IO, that's mean the variable here is a volatile one, so the compiler does not do an optimization with this variable. It's so important. You have to add the IO before every variable. So here we add the delay. We're gonna define this variable, this function. So we copy this and we paste it right here, and we're gonna define our little function here. So we're gonna create a new variable. I'm gonna call them timing delay, and we're gonna affect the time to the timing delay. So here initially the time is about 500 and the timing delay is also about 500. So now to write your code in the interruption handler, we open the STM32F4 IT source file. We bring him here, and we go directly to the SysTick handler. So in every interruption, the microcontroller interrupt from the main program and to go to execute the instruction inside the SysTick handler. So it's simple. We're gonna create a condition here. Gonna put timing delay, so is different of 0, and we're gonna create our code here. So before moving forward, the timing delay is declared in the main. So to let the IT handler to have access to this variable, we have added an extern before in the main program, and we declared again without using extern in this in the IT handler. So the timing delay, what we're gonna put in the timing delay, so we're gonna decrease the timing delay. What does mean? So in every, so the interruption, we know the interruption is triggered in every 1 millisecond. So in every 1 millisecond, the program inside the interruption, the SysTick handler will decrease in the timing delay variable. So we know initially that the timing delay variable is about 500. So this delay will take 500 millisecond. So before finishing here, we have to add a condition here. The timing delay is different from 0. That means the microcontroller still inside the delay function till the timing delay reach the 0. So now we finish our function. We try to execute to compile and see we have 0 error here. So as you can see here, the LED number 6 is toggling, so everything work okay. So we can replace the LED 6 by the LED 5 and we will see the result here. We execute another time and the red LED is toggling each 500 millisecond. So that's all for my tutorial. If you enjoyed watching my video and found it interesting, please click on the like button and subscribe it. And don't forget to check my website. And if you want to see my homemade UV exposure box for PCB production, please click on the right top corner. That's all. Thank you for watching and see you next time for more tutorial video.